let's do it. Never mind. Okay, I'm not following.
We're live. Everybody act natural. Okay, so. Yeah, they're gonna go like, yeah, there are. So really, probably this part won't be a lot on YouTube. I'm just sort of taking a snapshot of the board here so that you can see the notes if you need to. And then most of what will be on will be what we do later on. But real quick here, the notes you're taking down. 5.2, we're talking about bisectors of a triangle. So we can have two different kinds of bisectors. What are they?
Perpendicular and angle.
Good, perpendicular and angle. Okay. Perpendicular bisector, you know exactly what that is, right? Perpendicular to the side, it goes right through the midpoint of the side. And we'll talk about constructing those with a compass in a second. And you can have three of those, correct? Because there's three sides. Okay, hopefully this will work. What I want you to do to start with is draw a big triangle on your paper. Okay, you can watch everything I'm doing up here. Sort of copy what I do. But just any old big triangle.
Does that have to use the ruler?
Yes, use a ruler. Use a straight edge, please.
Any triangle?
Any triangle, doesn't matter. Just something big and try to make it straight. So don't freehand it. I have some straight edges up here. Can you borrow them? Up on the sill here. Okay. We are going to draw the perpendicular bisectors for this triangle. This is a homework problem, I believe. Okay. So, do we need to refresh our memories on how to do a perpendicular bisector?
Yes.
Okay. So let's put this aside. Let's get. No, just flip it over. Use the back. Okay, we've got a segment, right? This could be one of the sides of our triangle. It's on page 34 of your book. We take our compass and we extend it to at least half the distance of the segment, or half the length of the segment. Really, more like closer to the whole length of the segment, just so we can get a good arc here. Okay, and then we draw an arc all the way through. And being careful not to change the width of our compass, we go over to this other point, do the same thing. And then we have these two intersections, right? One right here, one up there. We connect those with our straight edge. That is the perpendicular bisector of that original segment. We'll call it AB. Okay, AB has just been perpendicularly bisected. Let's see if I can get the focus a little better here. That's as good as we're going to get. Okay? Does that make sense?
Yes.
Okay? Now, bring back your triangle. We're going to do the same thing for each side. So we're going to do that 3 times. So let's say this is our distribution set. Let's say we actually had this on a map. This was point A, B, and C, and we wanted to find exactly an equidistant point from each one of those places. Why are you laughing?
So I said a funny joke.
We can't use names. Can't use names. Then we have to sign waivers.
We do?
I don't know.
Oh, so
Okay, we're starting with our bottom segment here, and I've already started drawing my arc. Okay. I'm ignoring the rest of the triangle. It doesn't matter right now. I'm only concentrating on AC. You see that pretty well?
Wait, how did you get that second arc there? Did you go from like
I went to the other point, right? We're looking at AC. So I started with C, drew my first arc.
Mine didn't intersect.
Then was your compass spread out wide enough or no?
Probably not.
Okay. And then I went over A and did my other arc, keeping the compass the exact same. We can't let it float on us. Okay, and then I connect my 2 points. That's a perpendicular bisector. Make sense? We all okay? What's wrong? You can do it. You can't have no in your heart. Okay. That was for that one side. Now we have to go to our other side. I'm going to zoom in so you can see this a little bit better. How nifty that is, right? Okay. So now I'm on AB, doing the same thing.
Okay, I got it. I'm caught up.
Okay, your diagram's going to get real busy here. Did an arc there, going over to the other point, do another arc. And connect those 2 points. Okay, now, if you want, you don't have to draw the entire arc, right? You're only interested in these points of intersection. So you can just draw, and I'll do it on the next one to show you, but you can just draw the little X's, right? So you've been doing that. It's really the easier, more clean way to do it. So, we've got our triangle. Oh. And our 2 perpendicular bisectors right now, they intersect right at this point here, right? So our next one, if we do it well, should intersect at that same point. Also, they all have to be concurrent.
So no matter what angle, like what kind of triangle you have?
No matter what kind of triangle, you got it. Okay. Let me see if I can figure out a place to do this. So, it's getting pretty busy, right?
Yes.
Okay, there's a couple. A or B, sorry, and then my intersection there and there.
I don't know how to do the third. Oh my god.
We did it. Just make it down.
So again, I didn't do the whole arc.
Mr. Williams, I think I messed this whole thing up.
Well, that's why you're going to be able to go online tonight and watch this again.
No, but this is as far as I got.
So you're good on the first 2, now do the third.
Yeah, but where do I do the third?
So you've only used 2 of the lines so far, right?
See, I'm not retarded.
Hey, we don't use that word, right?
Oh,
Especially not on film.
You have to edit it out. Yeah.
Yeah, we're going to have a big muted section now.
It's not Serena, stop.
Because of somebody won't name names.
I did.
Okay, so take a look at this diagram now, guys. This is what it should look something like. Okay, my 3 perpendicular bisectors all did intersect at the exact same point, so I was able to do this pretty well.
So did you draw point there? Mine were really close.
So you can draw that and label it if you're asked to, whatever point P. I don't know.
Because the point was big, this matters.
Okay, and again, the relationship, the special quality about that point is what? What do we know? What's the special characteristic about that point?
It's right in the center of the triangle. No.
More specifically, though. Equidistant from
The sides.
The vertices.
the vertices, right? Because these are perpendicular bisectors, not angle bisectors. Where the angle bisectors intersect is equidistant from the sides. So, we're almost out of time. But you can do the same thing for angle bisectors. Alright, you remember how to bisect an angle?
Yeah. Yes.
Let's do it real quick. This one is on page 36 if you need to reference it.
35-36.
Okay, we start with our compass pivot at the vertex of the angle. Open it up to some arbitrary length, not too critical, and sweep it through both sides of the angle, like so. Okay. Good. Then we go to, and we can change the compass at this point, but between the next two steps, we have to keep it the same. So get it fixed at whatever you want it. And then we're going to go to one point, one of our intersections, and sweep out an arc in the middle of the angle. And do the same thing from the other. Somebody's watching the movie, aren't they? Okay, and this intersection right there, we connect with the vertex. That's an angle bisector. Okay. Sound like sort of familiar? Yeah. Wonderful. So now we do the triangle.
Oh no. So close.
Yes.
I would not. Thank you.
Can I give us a label? It's ABC. Okay, let's start with, any one. I'll start with B. I'm going to do the angle bisector. So again, sweep out my R. One intersection. Make sure, might not have gone long enough, make sure you go long enough here. Okay, and then go ahead and do the other two also. Do angle A, angle C. Not close. So this one, I wasn't quite careful enough, was I? Obviously not. All right, so that's your golden standard. You got to do better than that. Okay? Got to do better than that. That's good enough for a B right there. Okay, all three. If you're careful, all three of those points, that should be one point where they intersect. Okay? So be real careful. I rushed this a little bit. Okay, and then what's the relationship about that point, assuming that it is a single point?
It's incenter.
It's the incenter, but what's the special relationship there?
It's 180 perpendicular to all the sides, equidistant.
It's equidistant from all three sides. So you can draw a perpendicular from that point to each side, and they should all be the same length, right? Okay, any questions?